so we're going to continue on with our conversation of velocities and other rates of change. This is part 2, so we're going to be looking at other rates of change besides velocity in this one. So some recapping here. Rates of change in applied context other than motion. That's what we're going to be looking at today. What is a rate of change function? A rate of change function helps us predict how a quantity will change over time. It can tell us when a quantity is constant, when it is increasing or decreasing, and how fast that quantity is changing, just to name a few things that we can look at. The rate function is the derivative of the original function. Derivative notation is not always used. So, for example, like I say, A of t could represent the rate at which a tank is filled with water. So I don't need to put the prime on everything for it to be a rate. I just have to describe it as a rate. Rate of change functions can be given as a table, a graph, or an equation. We're going to look at all three of those, hopefully. And no matter the story, the same key skills are assessed on the AP exam and for my class. Finding or approximating a derivative at the rate of change function, interpreting a derivative value in context using correct units, determining when a quantity is increasing or decreasing based on its rate of change function. These are the things we're going to be asking you to do. Okay, so here's an example. It's a calculator problem. So we'll need a calculator to assist us with that. And so you'll want to use your calculator to go through the works of this problem. So here we go. Let's do this problem right here. It is people enter an amusement park at a given rate, at a rate given by this equation. So this is the rate at which people are entering the park. E of t is measured in people per hour. So E of t is a rate. And t is measured in hours after midnight. Find E prime at 11. Using correct units, interpret the meaning of this value in context of this problem. Okay? So those are the things we need to do. And so, how do I go about doing it? Okay? Well, I have this equation right here, and we want to be able to find E prime at 11. And we're going to use a calculator because we are not going to find that by hand. So, how do I do this numerical derivative? So let me go ahead and clear up a new document for you, and I will walk you through it. So I have a normal screen here. I'm going to try and get the glare out. Okay. And if I go to menu, I will see that number 4 is about calculus. Again, my calculator has more functionality than yours, so you want to make sure that you find the one associated with yours. And we want to find the derivative at a point. We want to find the derivative of E at 11. So that is the derivative at a point. That's number 2. And you'll get the screen right here. So what is our variable? X. I know it says a t right here, but we're going to put it in x instead. What is our value that we're going to do? Well, we're going to plug in 11. This is the derivative of this, so that is a first derivative. Hit OK, and it gives me this setup. So I'm going to take the derivative of what function evaluated when x is 11. And I have to type that in. So type in your fraction, 15600. Down below, we'll have an x squared minus 24x plus 160. You could put t in here if you wanted. You just have to change the variable on that other screen to t and make sure that you type in the t on your calculator in here for the variable. But I just do it as an x just because that's what I'm comfortable using. Once I have this, I hit Control Enter to get an approximate value, and there you go. So what is the approximate value of this? It's rounded 3 decimal places, so 107.958 is what I'm going to put down. 107.958. That is the value of E prime at 11. Okay? And now we need to use correct units and interpret this number in context of this story. Okay? So what is this right here? Well, this is a time. And we had our sentence frame from before. So here's what I would write. At 11 a.m., because it says T is measured in hours after midnight, so 11 would be 11 a.m. The rate, now describe the function E. What is the function E? It's the rate at which people enter the amusement park okay? Because that's what E stands for, people entering the amusement park. That's what that stood for. And what is it doing? Because this number is 107 positive, it is increasing at a rate of 107.958 people per hour, because that was the units of E, people per hour, because I took the derivative of this function, which was a rate, and then made it the derivative of that, which made it the rate of a rate. And so that's what E prime stands for. So it is this many people, it is increasing this many people per hour. That's what it stands for. And so that is how you would write that answer. Okay? Let's look at another question right here. A local bakery opens at 7 a.m. and the number of people in the bakery can be modeled by B of T over the interval between 0 and 8. So this formula works between 0 and 8. T is measured in hours, and 7 a.m. corresponds to 0, equals 0. Is the number of people in the bakery increasing or decreasing at 1 p.m.? Explain your reasoning. Okay? So, a couple things we have to do here. Number one is we have a time that we're looking at, 1 p.m., but that is a time, and I need to correspond it to a value for T in this equation. Since 7 a.m. is 0, then 1 p.m. corresponds to what value of T? It corresponds to 6. Okay? And so we're going to use that number in our problem. And it says what? Is the number of the people, that B stands for the number of people in the bakery, okay, at any particular time T. So is the number of people in the bakery increasing or decreasing? So by asking that question, I'm asking you to find the rate of change that is occurring when T equals 6. I'm asking you to find that value. Okay? Increasing or decreasing requires us to find the derivative of the function you want to determine if it's increasing or decreasing. That's its job. The job of the derivative is to determine if the original function, one of the things it does is if it's increasing or decreasing. So just like we did up above, this is a calculator problem. So we can come over here and do exactly the same thing again. Go to menu, number 4, derivative at a point, variable x. The value this time is 6. And then we type in our B of T function. Okay. Since this is a trig function, you want to make sure that you are in radian mode, which I am. And so we type in what we see right here is 24.6 times the trig sine fraction. And we have pi times x over 10 outside the parentheses times 8 minus x. Yes, I put times between the parentheses. I want to make sure that things are being multiplied. Just having a parenthesis next to parenthesis does not mean the calculator will read it as a time. Make sure you put your time stuff in there, okay? So there's my derivative that I need to take. Control Enter, and I get that number right there, which at 3 decimal places is a negative 28.172. So that is the number for our problem. Now, I need to interpret this in context. Even though they didn't specifically tell me that's what I need to do, it says explain your reasoning, so I need to put it in context. Okay? So just like before, using our sentence frame, at 1 p.m., the number of people in the bakery is doing what? Well, because this is negative, it is decreasing at a rate of, now decreasing means the negative, so I don't need to put in a negative number here. I need to put in the number 28.172, and then this was given in people in the bakery, okay? And so then people per hour, because B of T was just a number of people, so that's that. Okay, that was the units for B of T as people, and then we took it as a rate, so it'd be people per hour. And so that would be my answer, and then we write because, and the reason why, explain your reasoning. Why do I say it's decreasing at this number of people per hour? Because B prime at 6 is less than 0, because it's negative. So make sure you answer the question that they give you. Explain your reasoning is, here's my answer because of that. This one was just find this number and give it in context. So there's the number, okay, and there's the context. So make sure you answer fully the question that they're asking you, okay? So let's take a look at this next little bit right here, some things that help us do some other stuff. Some of the problems are going to get a little bit more involved, okay? Particularly when I have problems where not only do I have something like in the amusement park problem up here, we had people going into the park. Well, you might get something where people are going in and also coming out. So that can be called a rate in and rate out kind of a problem. I usually call that a given rates problem, but it's all the same depending on whatever you call it. You have a rate at which people are going into something and a rate at which something is coming out, okay? Some quantities are determined by two rates, a rate in and a rate out. The number of people in a soccer game is determined by the rate that people enter the stadium and the rate that people leave the stadium. The volume of water in a tank is determined by the rate at which water enters the tank and the rate at which water leaves the tank. If you have both. I mean, this is just sometimes. If you just have a tank where water is only going in and not coming out, then there's only one rate in, there is no out. But sometimes if I want to find how much water is in a tank and it's water is going in and out at the same time, that's why. Determine whether a quantity is increasing or decreasing at a specific time or interval. We can compare the rate in and rate out. Here are some tips for dealing with these kind of problems. This problem, by the way, is going to be an AP test question. It is one of your major question types. And here are some things to think about. These problems are typically on a calculator. Start by typing in both functions into your calculator as F1 and F2. So in other words, you might want to put them in the graphing aspect in your graphs. Graph the two functions. Okay? Because once it's in there and you have it in properly, so double check your type. Make sure you have typed it in properly, both functions. Then you can use that calculator, because it's usually a calculator problem, to help us find what they're looking for and to do things. Because I will show you how to do that on the calculator. You're going to define a new function, clearly labeled on your paper, that represents the overall rate of change, which would be the rate in minus the rate out. You're going to use the function names for this, not the equations. I'll talk about that in a minute. You can get transcription errors if you always do this the other way. Put this equation as F3 in your calculator. And I'll show you how to do all that also. Here is an example that we're going to be looking at. See if you can see it here. All right. The penguin population on an island is modeled by the differential function E of t for 0 to 40, and t is measured in years. P of t is the penguin population. There are 100,000 penguins on the island when t equals 0. The birth rate of penguins is modeled by B of t, and is this equation right here. I know it's kind of hard to read, but it's basically 1,000 times e to the 0.06 t, and that is the rate at which they are being born, and that is penguins per year. And the death rate is 250 e to the e to the 0.1 t penguins per year. Is the penguin population increasing or decreasing at 5 years? Give a reason for your answer. Okay? So, we need to write, to determine if the population is increasing or decreasing, we have to find that rate of change. This is the rate of birth. This is the rate of death. So we will define a new one, and this is how you do it. Let, in this case, I'm just going to call it R of t, which is the birth rate minus the death rate. So this is a rate. And I have to define what this is. So what is this? This is the rate of change of the penguin population. Okay, so you define it. Once I have defined it, then I can use this to determine my answers in these things. So I want to find the rate of change. Is it increasing or decreasing at 5 years? Okay, so you can also call this D prime because P is the population of the penguins, and I could have called it D prime of T to be this. I mean, it's the same thing. I don't know why I chose R, but I just did. All right. So how do I do this? Well, I need to get these two equations into our calculator. So let's do that. So I'm going to I'm going to start a new page. Okay. And I'm going to do a grapher. And here's F1. Sorry, you have glare. So here's F1. So I'm going to type in the birth rate equation. 1,000 times e to the 0.06x. There's that one. I'm going to bring up another line. There's F2. I'm going to type in the death rate, 250 times e to the 0.1x. And I graphed that one. So they're both in there now. Okay. And now, what about this one down here? What about R of t, where it's B of t minus that one? Remember, in our calculator, B of t is F1, D is F2. So I'm going to make a new one called F3. And F3 is going to be F1 minus F2. Okay? So how do I do that one? Well, if I hit the variables key, I'm pretty sure this is where it is. Let me double check. Hit the variables key, and that is not what I want. Or wait a minute. Let's see if we can go down. Come on. What was that? Nope. All right, let's escape out of this. But anyway, I'll have to figure this out. I don't want to take more time on this one, but there's a way to get into the variables. I just forgot how to do it. And I'll have to deal with that in a minute. Okay, but when you do that, you type that in, you find R at 5, you're going to get 937.678. And because that number is greater than 0, I know that we're going to have an increasing. So then I come over here and I write my final response, give a reason for your answer, okay? And so you can say, in year t equals 5, the penguin population is increasing at approximately 937 penguins per year. And I do that because of the fractional penguin part. And basically that means that the birth rate is greater than the death rate. Okay? And because this is greater than 0, so that explanation right there indicates that this here then is an increasing function. And so all of this would be my answer. All of this. It's important that you define what the new function is, find your value, and then you interpret your answer accordingly. Okay? So let's look at the next one that I have. In this example here, I have a picture involved. Okay? So in this one over here, the rate at which people enter a museum in people per hour, okay, is given by M of T. T is measured in hours after the museum opens. The graph is given. Starting at T equals 1, people leave the museum at a constant rate of 45 people per hour. So starting here, in the first hour, no one's leaving. At T equals 1, then people will start leaving at a constant rate of 45 people per hour. Part A, find M prime at 3. So what is M prime at 3? You don't have an actual function, okay? You only have a picture of a function. So to find M prime is implying that I'm looking for the slope of a curve at 3. Well, this curve is made up of line segments. So at 3, you're on that segment right there. So the line tangent to the curve at 3 is the same as the slope everywhere on this line. And the only way to find a slope of this line right here is doing secant slope kind of a thing, the difference quotient. So this is equal to M at 5, which is this point up here. This is 5 and 100. And this point right here, which is 2 and 40. So M at 5 minus M at 2 over 5 minus 2. And you work that out. Remember, always write that down. Then you can plug in the numbers for it. And then you can get your answer, which is 20. And then we've got to figure out our units. All right? The units for M are measured in the rate at which people are getting in the museum is M of T. T is measured in hours. Okay? And so then we are looking at M is the people per hour. So then there's 20 people per hour So that would be the answer to M prime at 3. And so then I can write that out in context. Okay? Interpret your answer in context of the problem. And so I would write at D equals 3 hours, the rate at which people enter the museum is increasing at a rate of 20 people per hour. So that would be how you would answer that question. So what about part B? What is the rate of change of people at the museum when T equals 4? Justify your answer. So again, in this case, at 1, people are going to start leaving at a constant rate. And then we have people entering at M of T. And so what is happening here? So then in this part, this is part A answer, this is part B answer. The overall rate of change of people at the museum for T greater than or equal to 1. Okay, because at 1, people are going to start leaving. So I am defining my new rate, M of T minus 45. This is the rate of people going in. This is the rate of people leaving. And again, I could have defined it as a new variable name if I wanted to. Okay. So once I have that, at t equals 4, the rate of change of people at the museum is m at 4 minus 45. And what does that give me? Well, what is m at 4? So you come over here, and the graph's not really perfect here, but it is 80. And then minus 45, which gives me 35. What? People per hour. So that would be our answer for that one. Okay, and I will work on that calculator thing. I did one small little thing, and I will get back to you on that one during class time. But these are the kind of questions we're going to be asked to solve.